Yeah, I will post the notes and hopefully a recorded version of the lecture on the Google Classroom. So go for it.
All right, thank you.
Yep. Okay. So here. Okay. Okay, so from here, our next instinct would be simply to cancel, right? So we have x plus 7 and x plus 7 in the denominator, and we're going to cancel them. Now, I would like everyone to take 30 seconds to tackle our first problem. And looking at the categories that we have above, what type of limit do you think this would be after also taking into consideration what we've simplified? Thank you, Brianna. So take 30 seconds to, again, it'll either be asymptote, substitution, or end behavior. And please type in your answer into the chat. Cool. Okay, so there does seem to be some confusion on this because I'm getting two answers. Okay, I saw Kalia, you actually switched from substitution to asymptote. So would you be able to come off mute and explain what made you switch and what was your thought process at first and like how did you switch to asymptote?
Well, at first I thought that you would have to substitute 3 from both sides, but then I realized that in the denominator, x minus 3 is an asymptote, so that's why I switched.
Awesome. Yeah, exactly right. So our first instinct here would be to directly substitute. Like anytime I see a limit of f of x going to like some number, like an actual number that's not infinity, that's always going to be my first instinct. I'm going to be like, what's going to happen when I plug it in? And if it works out, then it works out. Like if I plug it in and then I get some number, like it just comes out to like 6 or something, that's great. That is a substitution limit and I solved it perfectly. The issue here is when I plug in 3, right, I'm going to get 3 minus 3 in the denominator. So I'm going to get a 0 in the denominator. And that we know is undefined. Well, it's not, it just can't happen, right? We can't have a 0 in the denominator. So when that happens, it's like, can we simplify this anymore? Can we remove can we change the equation so that there's no 0 in the denominator? And the problem is that we already kind of did that earlier, right? We tried to simplify our equation as much as possible. This is what we're left with. We're left with x minus 8 over x plus 8, x minus 3, x minus 7. There's no way for us to simplify this anymore. We already factored it out and then canceled everything. So yes, so indeed at 3, we are going to have an asymptote because when you plug in 3, there is no, like we're going to get an asymptote at 3. So this means, again, when the limit is approaching, we'll either go to positive infinity or negative infinity. We have no idea, right? So Kalia, could you actually come off mute again? And what would your like method be to solve for like a limit near an asymptote? Like how would you try to figure it out where it's going?
To be honest, I'm not sure.
Okay, that's totally fine. Would anyone be able to volunteer what they think Remember, this is the same technique we use to solve for any asymptote limit. How about Ruchar? And thank you for everyone who's volunteering.
Would you try to like find out what's going on from both sides? So if it's approaching from the left and approaching from the right. Try to plug in.
So that's a good way to think about it. So again, for asymptote limits, the method is very like brute force. We just plug numbers in. So if we know that, actually, I'll just draw this here again. If we know that this limit is either going to positive or negative infinity or something, we can just plug in a number over here and see if it's really negative or really positive to tell us if the limit is going to positive or negative infinity, right? It's possible that this limit is going down here, this is going up, we plug in a number and it comes out to like negative 100. That'll tell us that the limit then is going to negative infinity because we can see that it's going like way down. And then if we plug in a number that's like just barely more than the asymptote, like maybe the asymptote's at x equals 3, right? If we plug in 3.1 and it's going to like some really positive number, I don't know, like 2000, then we know it's going to go to positive infinity. So again, let's just try out that method. So for a limit as x approaches 3, I'm going to come from the left, right? And coming from the left, I'm going to plug in, let's say, 2.99, right? I'm going to say here, all right, x equals 2.99. Well, this is really close to the asymptote of 3, right? It's really close to 3. It's coming from the left. So we're going to be able to tell when we plug in 2.99, I'll just give the answer. I get an answer of 45.5. So I'll put f of. So just in the chat really quick, so where would, if you see a number 45.5, where would this limit be going to? Yep, exactly right. So it's going to be going to positive infinity. And all we did that to find that out is we didn't prove it necessarily. We just plugged in a number that's really close to the asymptote and saw that it's going up, saw that it's going really like positive. So it's going to positive infinity. In contrast, let's say we went from the other end, the limit as x approaches 3 from the right of f of x. Kalia, would you be able to come off mute and suggest a number that we could plug in if we're trying to see like where the limit is approaching from the right?
3.1, I guess.
Yeah, 3.1. In this case, for this problem, I'm going to use 3.01 just because we get a better answer from it. But yeah, 3.1 is a great place to start. But basically, we can choose any number that's really close to 3, but not actually 3, right? And that's coming from the right. That's greater than 3. So f of 3.01 is equal to, I did the calculation separately, but it's equal to negative 45.5. So quickly in the chat, where would this be headed to? Awesome. Yep. It's going to negative infinity. Cool. So what we know about this asymptote is basically opposite of what I first drew, of what I drew there. So from the left, we're going to 3, right? This is 3. From the left, we're going to positive infinity. So this function is coming here, and then going way up. And then from the right, it's going close to the asymptote, and it heads way down. Remember, it's an asymptote, so it never actually crosses this point. But that's basically the function. That's what we're looking at. But ultimately, the limit is asking us, as x approaches 3, from the two-sided limit. So what do we know about the two-sided limit? And what do we know about these two answers that informs us what the overall answer is? So what would the overall limit for f of x as x approaches 3 be equal to? Yep. Thank you, Kalia, for sharing that. It does not exist because one's going to positive infinity and one's going to negative infinity. The limit can't exist, remember, because the limit only exists if the two-sided limit is equal to each other. So if they were both going to positive infinity, that's great. Then our limit is positive infinity. If they're both going to negative infinity, then that's also great. Our limit would be negative infinity. But since they're going in completely different directions, right, the limit just won't exist. Awesome. So I'm going to give everyone 20 more seconds or so just to fill this in. Okay, so this next problem, I'm going to give everyone 1 minute to try to solve this problem. Limit of f of x as x approaches -7. Begin now. And once you have your answer, just please type it in the chat. Or actually, for now, just kind of figure out what the type of limit would be and type that answer in the chat. Thank you, Kalia. Awesome, thank you. I would like to see a bit more participation in the chat. So for limit of f of x as x approaches -7, and this is our function, right? We simplified our function to this. What type of limit would this be? Would it be an asymptote, substitution, or end behavior?
Would it be a whole?
Sorry, I'm not sure who that was, but you can come off mute and share what you wanted to say again.
Removable discontinuity because x plus 7 was in the equation, it was crossed out, so and then it would become x equals -7.
Yeah. So yeah, you're actually going into more detail. It is a removable discontinuity, but we try also in terms of asymptote and substitution and behavior, how would we ultimately solve for the limit? What method would we use?
Substitution, since there's no asymptote there.
Yep, exactly right. So this would be substitution. And the reason is we can just, after we simplify this, of course, we can just directly plug in -7 into our equation. Notice how it's -7, it's not 7. So we're not going to get a 0 over here, right? So we're just going to plug in, put -7 into equation. So we can get f of -7 equals -7 minus 8 over -7 plus 8 times -7 minus 3 times -7 minus 7. Notice how there's no zeros in the denominator. This -7 term is -14, not 0. So let me simplify this really quick to -15. I did this calculation already, so it's -15 over 1. Okay, so we just substitution, just put the number into the equation, and we get a nice number that actually exists. Remember, for the asymptote, we can't do that. We plug in a number, and then we get a 0 in the denominator. I'm going to give everyone like 30 seconds to copy that part down. Okay, so I just got a question from Jennifer about how did I know that 3 was the asymptote in this first question. And there's only a few minutes left, so I'm actually going to answer this question instead of moving on to the rest. But would you be able to come off mute again and explain how you know that 3 is an asymptote?
Because for x minus 3 in the denominator, it's a unique value, I guess. I don't know. Since it's a vertical asymptote.
Yeah, so yeah. So it does prove that there's a vertical asymptote. So to answer your question, the reason is that when we plug in 3, so this is a really bad, I don't really have much space to write it, but I'm going to write 8 over x plus 8, x minus 3 times x minus 7. If I plug in 3 here, I'm going to get a 0 in the denominator, right? Because 3 minus 3 is equal to 0. So then 0 times any of this is also going to be equal to 0. So I'm going to get a 0 in the denominator in the end. I don't even care, like 3 minus 8. And when there's a 0, that means that there's an asymptote because it can't exist. So like the function can never go there. So that's how we know there's the existence of an asymptote. And then just graphically, an asymptote, you'll see asymptotes, you can tell when graphs like go near it, and then it's like they're almost afraid of it. You can't cross an asymptote. That's not allowed. You either like go way up or way down. You go to positive infinity or negative infinity because you can't cross an asymptote, again, because it doesn't exist there. We already tried. We plugged it in and it doesn't exist. So hopefully that answers your question, Jennifer. So Jennifer asked a follow-up question for why 7 isn't an asymptote. 7 is an asymptote. The thing is, we looked here, over here, it's -7. We weren't looking at 7. 7 is indeed an asymptote. -7 is not an asymptote though, because when we plug in -7, we're going to get -14. So yeah. Okay, so there's 1 minute left in class. Actually, just hit 50 now. So again, usual stuff. Remember to turn in your exit ticket, your class notes by 10 p.m. Start working on your homework packet. Just doing a couple problems a day, and you won't have to stress about it at all by like Thursday night or anything like that. If you have any questions, email or text me. And yeah, and that's it. Have a good day. See you all tomorrow. Yeah, there's no stamp for the notes today. We were just doing review, so don't worry about that. Right. Thanks, Kayla. Have a good day. Thanks, Jennifer, for the questions. Again, if anyone else has questions, I can stay for a few minutes after class.
Mr. Wang. So
Yeah.
for today,
What's up?
like all we're really turning in is classwork and note that's to get notes.
Yes, that's today's notes.
And the packets due like Thursday, right?
Yeah, Thursday night at midnight.
Okay.
Yeah. You have any questions about that or concerns or anything?
Not necessarily. Just like I don't know. I tend to find myself like doing the work in class, and then as soon as you hit the exit ticket and it's something that looks different from when I was in class, I kind of go blank. Like I don't know what it is for me. Like me and math just don't click. I don't understand.
Okay. Wait. Yeah, that makes sense. Wait, could you? It was hard for me to hear. Did you say like doing problems outside of class is different? Is that what you were saying?
In a way, yeah. Yeah, it's kind of.
Okay. Yeah, like when when it's not exactly like the example problem, it's like kind of weird.
Yeah.
Okay. Yeah, that makes sense. I feel like that's kind of just math can be hard that way. I'm gonna try my best to post some videos that like correspond to the packet. But yeah, again, if you have any questions about specific problems on the packet, just message me.
Okay. All right.
Okay. Good luck. Yeah.
Thank you.
Thank you though.